Today we are going to discuss the last topic in module 2, which is RC4. Okay, now RC4 is a stream cipher, and we already know that in stream ciphers we take one bit or one byte at a time, and that byte is converted into the cipher text with the key. Okay, so this is a stream cipher, and a pseudo random number generator is used to generate the key stream. Okay, now we've already discussed stream ciphers in module 1 in detail, so I hope you will go there and go through it if you do not remember it. I am going directly for RC4. Okay, RC4 is a stream cipher. It was designed by Ron Rivest in 1987. Okay, theoretically it is broken. The security is broken for RC4, but in reality it still works. Okay, and this cipher is owned by RSA DSI. RSA is another algorithm designed by Ron Rivest and other researchers. So we will be looking at that later. This RC4 is also owned by them. Okay, now the advantage over here is that the key stream is randomly generated, and the different sizes of keys are possible. But just like all stream ciphers, it is byte oriented, and it is used normally for encrypting internet encryption, web encryption and wireless encryption. Okay, so we're going to look at how this works. The first thing is how the key is scheduled. Okay, it's very simple calculations, but there is a method in which the key is scheduled. First of all, there is a state array S of 256 bytes. Okay, and the array is simply initialized from 0 to 255, so 00 to FF. Okay, so S is an array with values from 0 to FF. Okay, and then in each step, depending on the size of the key, we shuffle the values inside this S value, and depending on which values are being shuffled, a particular key value is calculated using an algorithm. Okay, we're going to see how it is done. Now, this S forms the internal state of the cipher, and how it's in this first instruction for I is equal to 0 to 255 do S of I is equal to I simply initializes the state array from 0 to FF. Okay, and then the next step is calculating a value T of I. Depending on what the current value of I is, T of I is calculated, which is equal to K of I mod K length. Okay, K of I mod K length. Okay, so the I is mod of the K length. So if it is 8, it will be I mod 8, and then K of I is assigned to T of I. Okay, so the ith key will be this T of I. Okay, then we are going to go for the actual swapping of the S elements in that state array S. First initialize j is equal to 0. For each value 0 to 255, do j value is calculated by adding previous j value plus si plus ti, and then mod 256. Okay, so this j plus si plus ti is calculated, and mod 256 is done to get the j value, and then depending on what j value is calculated over here, si and sj are swapped. Okay, this much is the key scheduling. Now from this j value and I value and t value, we can actually calculate the key, which is also taken from this state array itself, but which value from the state array should be taken is decided by this si and sj. Okay, so the shuffling process and getting the values of I, j and t is what we have done over here in the scheduling. Okay, now we are going to look at how the actual encryption is being done. Okay, Now for encrypting, continuous shuffled values, for each byte we take a different key value. So continuously the shuffling is done, and depending on what I and j values and t values we get, we calculate the key that is going to be used for that particular byte. Okay, and since it is a stream key and a stream cipher, each byte you can do the same process. Okay, so now how the actual encryption is being done. We are using, we already saw how t is calculated. S of t is going to be taken to do the cipher of, that is stream cipher of a particular byte. Okay, so for that actual message encryption or decryption, I is equal to j is equal to 0. First it is initialized to 0. Then for each of the byte m of I, we will calculate I is equal to I plus 1, previous I value plus 1 mod 256. J value is calculated as j plus s of I, it will be taken from the state array, j plus s of I mod 256. So now we have values for I and j. Then si and sj are swapped. So the key scheduling is done. Now we have the values of the state array from which we are going to get the key value. Okay, how to get the key value? T is calculated, where T is simply Si plus Sj mod 256, and depending on what T value we got, S of T is the actual key, and simple XOR operation on that byte with S of T is done to get Ci. To do the decryption, again use the same S of T and XOR Ci to get Mi, and with that encryption is done. The process selecting the key is the encryption security. Once the key is selected, a simple XOR operation is done for encryption and decryption. Okay, so this is a consolidated diagram. So initially we are initializing the state array S, and from the state array S we calculate the T's depending on what length, key length we have, because based on the key length we calculate the T's. Once this much is done, then the j value and I value is initialized one by one. So j value is calculated as j plus Si plus Ti. Okay, and these j values are then going to be used for the permutation. Si and Sj will be swapped. Okay, so Si and Sj values will be swapped. Once the swapping has been done, then we calculate j is equal to j plus Si. We are going to do the actual encryption. For that we have to find the value j is equal to j plus Si, and then T is calculated as Si plus Ti, and from that T position of S of T we get the K value, and this K value is XORed with the byte, that current Mi message byte, to get the encryption. And to do the decryption, again the same K value is XORed with the ciphertext to get the original text. Okay, so RC4 security, many analyses have been done, but there are no practical attacks which can actually be used to break the security. Okay, the result is the output is very non-linear, so it is relatively secure. Only problem is, since it's a stream cipher, we should not reuse the keys. There is a problem with WEP, wireless encryption using RC4, but the problem is not actually the algorithm of RC4, only the way in which the key is being handled. So distributing the key securely is the problem when using RC4 with wireless encryption. Okay, so we can see that theoretically, even though there are attacks which can be done on RC4 to break its security, practically it has not been broken. And with this we come to the end of module 2. We'll continue with module 3 in the next class. Hope you have understood this. For any doubts, please feel free to contact me, and don't forget to like and subscribe. Thank you.